divide for many parts, okay, for many slides, to ensure that you understand and can follow one by one. Okay, actually for this chapter, we will go into details, okay, on the design of reinforced concrete beams. Okay, but before we go further for the design, you need to understand all the materials that use for reinforced concrete beams. So the first materials here is material properties for the concretes. Okay, for the concrete we have for RC beams we have concretes and also steels. Okay, so we go one by one. Loading pula. All right. For concrete, you need to know where's the strength come from. Okay, so that's about strength of concrete. You can refer in the EC2 in the clause 3.1. Okay, so that this is your jobs to find out where's the clause. Where's the clause is in the EC2 here. Okay, for the strength of concrete, we label as a FCK. Okay, as a strength, C for the concrete, K for the characteristic strength. So FCK here, or the strength of concrete, normally, okay, for the designs, we will refer for the strength on 28 days, okay, that is tested for cylindrical strengths and also cube strengths, okay. As you can remember, okay, let's say this is the load of this of the concrete, and then you do the compressions test for 7 days, for 14 days, right, for up to 28 days here. Then you plot the graph. Okay, so on 28 days here, that is we referred as a FCK, okay, for the concretes, which is on 28 days the concrete achieve about 100% of the strength. Kalau 7 days, it almost achieve 70% from the strength, and then 14 days almost achieve about 90% of the strength. Okay, and then up to 28 days, it achieve about 100% or about 99% of the concrete strength. Okay, so that's why we do the testings gradually from 7 up to 28 days. Actually, mostly this carried out by a researcher for investigation, for the research. Okay, we want to know the development strength for the concrete. All right, so we have two here, cylindrical strength and also cube strength. So that's why in the EC there will be a two strength here. The first one, the first value is a strength for cylinder. Okay, the first value is a strength for cylinder, and then the second value is a strength for cube concrete. Okay, that means in one batch of fresh concrete or dalam satu bancuhan konkret, so kita kena sediakan dua samples for cylinder and also for cubes. Okay, for the cube here. Untuk size cylinder, Okay, this is the two tests for cylinder and cube. Untuk cylinder normally about hundreds times 200 ataupun 150 times 300. Okay, which is dia punya height. It can be 200 or can be 300. Okay, while its diameter can be hundreds or 150, which is the height is just a double up from the diameter. So this is example the sizing for the cylindrical mold. Okay, kalau cubes it should be might be hundreds times hundreds or 150. Okay, so this is the two size for the cubes. So if you look at in these tables, once it mentions C20/25 here, it means the first value here is a strength for the cylinder. The second value here is a strength for concrete. For the cylinder, strength is lower compared to the cube here. Okay, because if you look at of the load how it applied here, so for the cylinder it have to apply along of this length, okay, which is 200 up to 300 lengths. So how it distributes also, the length also will affect the value, will affect the strength, but this one still in one batch of mix of the concrete. So for the design we will refer for the cylindrical strength, okay, for the cylindrical strength, which is C20 here, okay, which we refer the lowest one. Okay, so that means 20 for cylinder, 25 for cube, and then this is the modulus elasticity for the concrete. So from the testing also we can come out with this modulus of elasticity. So the strength of concrete, it can be from normal to high strength concrete, depends what's the functions of that buildings. Let's say just for a common building, we can just use for the normal strength of concrete, which is from 20 up to might be up to 45 here. Okay, and then more than it, we can consider as a high strength concrete. So high strength concrete might be can be applied for high rise buildings, or might be for the bridge. Okay, depends the load that will be resisted, what is the function of that structure. Okay, all right, from the tastings, okay, from the curve here, okay, from this plot here, we can come out with the stress and strain curve. Okay, stress and strain curve here, which is this stress here is a P divided by area. Okay, let's say you applied the uh, load to this cylindrical mold here, cylindrical concrete here. Once you apply the loads gradually, so that's mean you can collect all the P here, all the load here. Okay, and then the load will be transferred to this area, which is the diameter, the area of this cylinder. So once you divide P or the load divided by this area, okay, you can plot for the stress of the concrete. So this is the stress here. Let's say load 5 divided by area, you can plot for the stress here. Load 10 kilonewton divided by area, so you can plot all the stress here. Well, this is the strain. Okay, remember about the symbol for the strain here is the epsilons here. So the strain is length or deformations divided by the original length here. So this is the original length. Once you apply the compressions, there will be some reductions of the length. We couldn't see it obviously, okay, but there will be um, instrument that we attach, okay, that we attach at the surface of the concrete, that we call it as a strain gauge. There will be a wire that attached at the machines, okay, to collect all the data of the strain here. That means all the deformations during the tastings here. Okay, so the strains here is equal to deformations, might be elongations, might be the apa ni, pertambahan atau pengurangan length, okay, then divide by its original length. That is what is mean by the strain. Okay, once we plot the graph here, it will produce this kind of curve here, okay, which is at the beginnings, okay, there will be a initial linear, okay, line here. Okay, and then after that there will be slightly curve until reach the maximum strain here. Okay, so this is the stress maximum, okay, that the concrete can achieve here. And then after that there will be a decreasing curve here until the concrete collapse, until it fail and everything. So at this point here, okay, once the concrete achieve the maximum stress, okay, the strains will approximately 0.002, okay, which is about 0.002 here. Okay, so that is the strains for the concretes. Okay, all right, so according to the Euro codes, which is EC2, in order to design the cross sections of the concrete, it recommends the idealized stress strain curve. This is what it means idealized. It simplified the curve. It make it simple in order to do the designs and then in order to come up with the equations. Okay, so if you look at this curve, FCK here is the originals, right? This is the 100%, which is the strength of the concretes, either by cylinder or by the cubes. Okay, which is what the simplifications here. It make the constants. Constant curve here. Okay, kalau sebelum ni dia ada curve and then drop right and then fail. Tapi for this idealized stress strain curve, it make it constant. After the maximum, the stress is constant, the load is constant until it reach the maximum, until it fail here with the maximum strain of the concrete is about 0.0035. Okay, so FCD for the design purpose. Okay, let's say for the FCK we consider about 100% of the strength because of we want to design, and then we also consider for the safety. There will be some safety factor and also coefficient that we will consider. So that's mean for the FCD here for the design, it's slightly lower that we will consider for the design. Okay, so for the safety factor of concrete, we will use about 1.5 here. So which we consider the design situation of persistent and transients, which is the normal or common situations. Okay, there's no impacts or accidentals or anything that is rare. Everything is just a common normal situation. So that's why we use the safety factor of 1.5, okay, for the concrete. You need to remember this safety factor for the concrete. Okay. In order to come up, so what's the FCD here, okay, which is the design stress for the concrete. You need to consider its coefficients here, okay, which is we take about 0.85%, about 85%, which is 0.85 from the strength of the cylinder. Okay, so that means this is coefficients, okay, alpha multiply with the actual strength of cylinder FCK divide by safety factor. So this is 0.85. Okay, and then safety factor for the concrete is 1.5. So you divide this value, then you will get 0.567 FCK, which is equal to FCD, which is the ultimate design compressive stress for the concrete. Okay, so you need to understand how the value comes from, and then what's the FCD for the concrete before we can go for the designs. And then the ultimate strength for the concrete is a 0.0035, which is this is the common strain value that we use if we use the class concretes less than C50 and 60, which is this is the highest one. Okay, so that means this will be the maximum strain value for the concrete, 0.0035, which is FCD here is equal to 0.567 from the FCK. Okay, so that's it for the concrete. Then we go for the steel. Kalau concrete is the FCD, kalau steel kita guna label FYK. Okay, so FYK you can relate to the yield of the steel. So that is how you can remember the symbols. Kalau FCD you can relate that C stand for the concrete. Kalau FYK, that Y is stand for the yield. Steel will have its yield strength, right? It have a yielding point. So FYK stand for the strength for the steel, which is the strength is within this limit from 400 up to 600. That is considered as a high yield reinforcement, okay, according to the EC2. So this is the range for the steel strength here. Kalau refer UK, the grade about 500, okay, 500 Newton per mm power of 2. So for the Malaysian, we use these two types of strengths, okay, which is FYK, it can be 460. The label is T. Kalau guna 500 FYK, so the labels will be H, which is this T and H special for the main bar. Okay, for the main bar. Remember, for the concrete beams, we have a main bar at the bottom one also. At the bottom one here, which is you can use besi T, boleh juga guna besi H. Kalau guna besi T, that means the strength of steel that you use is a 460. Kalau guna besi H, the strength of steel that you use is a 500. Okay, so either 460 or 500, it will be included in the calculation. Kalau guna 460 dalam calculation, you need to calculate based on 460. So that's why you need to know which one that you will use as a main bar. Okay, kalau guna besi T, that's mean you punya apa ni? Labels. Let's say ada 2 bar. So you akan guna label 2 T, let's say diameter 20. Okay, so we will know that you use two numbers of 460 strengths, okay, of the bar. Kalau guna H, so you will note that as a 2H20. So that means steel reinforcement that you provide for this beam with the strength of 500 Newton per meter here. Okay, so kalau untuk links, so kita akan guna mild steels, okay, with the strength just 250. Okay, this is the links here, which is you arrange with certain spacings. Okay, so the links will use mild steels, which we will label as a R. Okay, stands for the mild steels with the strength of 250. Let's say this links used with the diameter of 8. So R8 is a mild steels with a strength of 250, and then spacing, katalah spacing for every 100 mm there will be a links. Okay, so R8 with the spacings of hundreds, ataupun every 50 mm there will be a links, so lagi rapat kan. So R850. So that is how we labels according to the strengths of the steel, according to the types of the steel. So for steel reinforcement, it can be divided into these 3 classes: class A, class B, and class C. So class A with small diameter, less than 12 mm. So that means R8 can be considered as a class A, which is dia punya diameter quite smaller here. Okay, any diameter less or equal than 12, we group it as a class A. Kalau class B, this is the common use for the reinforcement bar. Okay, class C for the high ductility, so might be used for the earthquake design. Is about the strength. That means from the lower strength up to the high strength of the class C. Okay, this is how we conduct the tensile test. Okay, for the steel reinforcement, you will need to set up this reinforcement vertically. So this is will be the fixed ones, and then this one also, which is the machines will be will pull out, okay, this steel reinforcements here until you fail lah. Okay, bila fail it should be putus kat sini. Okay, there will be a necking here. If you look, you can see here how the decreasing the diameter of the bar, okay, because of this tensile test. Okay, so the diameter here reduce, right? Okay, until it's split into 2 here. So from the testings, okay, this is we can come out with the maximum strength here. We will know what's the maximums until the steels fail here, which is, and then we plot the stress strains curve. Again, this is the same concepts. Once you apply the loads and then you divide by the diameter of these steels, okay, katalah diameter dia berapa, 20. So you calculate what's the area for this steel, okay, pi d power of 2 divided by 4, right? So every loads gradually, continuously will be divided by area of the steel. Then you can plot all of this curve here until failure. Okay, until failure. And then you also will know what's the maximum stress here. Okay, if you look at of this stress strain curve for the steels, there will be a two-part, okay, that splits between elastic and plastic limit. If you can remember, this is the linear one, okay, so which is its proportions, berapa stress, itu juga you akan dapat strains. Okay, strain value. This proportion here is a linear at the beginnings until you reach the limits. This is what we call it as a yield, okay, as a yield point, as a yield strength that we will refer for the designs. Okay, this region is the elastics regions. Okay, that means the material can back into its original length. It can like a springs, right? Which is these steels. Once you apply the load and then up to a certain limit, you stops and then release back the load. So the steel will be back to its original length. Okay, that what is meant by elastics regions. Okay, so once it reach these limits, or also we call it as the elastic limit, which is this is where we can know what's the yield strength here. Okay, after this limit, there will be a plastic regions. Plastic region is from the elastic limit up to failure. So this is the plastic region where the material couldn't back to its original length. Okay, it becomes widens, it becomes longer. Okay, up to failure. Which is this is the maximums. Okay, maximum strength. So you need to understand the behavior of the steels, the properties of the steels. Okay, so for the steel also, they also have a idealized curve, which is simplified. Okay, simplified from this original curve, original performance, to becomes more simple curve that we call it as the idealized curve, which is after the limits, all the line after this it becomes continuously. Okay, it's not constant. This is the constant ones, right? It's not becomes a curve. It becomes one line here. Okay, according to its increments. Okay, so again, this is the FYK, the maximum one, the originals, the 100% strength. But for design, we refer on its FCD, which is we consider its safety, we consider about a safety factor. That means the FCD value will be slightly lower compared to the originals one. Okay, for the safety purpose. All right, so this is the standard modulus elasticity for the steels. Okay, different material will have a different modulus of elasticity. Okay, kalau steel dia punya modulus adalah 200. So how to know or determine this modulus of elasticity is based on this linear curve, right? Okay, which is E is equal to its apa ni, dia punya slopes here, which is y2 minus y1 divided by x2 minus x1, which is y2 here, y-axis here is a stress, so that means stress divided by x is the axis for the strain, so stress divided by strain. So that's why some of the equation you will find that stress is equal to modulus and multiply with the strain. Okay, so then we look at what's the FYD here. So FYD is according to the safety factor for the steel. Tadi safety factor for the concrete is 1.5, right? So kalau steel, according to the persistence and transition situations here, the safety factor for the steel is 1.15. Okay. Kalau safety factor for the concrete is 1.5. So safety factor for the steel is 1.15. So again, it's the same concept, which is FYK, the strength of the steel, divided by safety factor for the steel. Tapi dia tak ada coefficient. Kalau concrete tadi ada coefficients, right, which is 0.85. Kalau steel, just divide directly the strength of the steel divide its safety factor 1.15, you'll get these equations, which is FYD is equal to 0.87 FYK. Okay, so if you summarize, which is FYD, okay, for the concretes, berapa tadi? 0.567 F CK, right? So untuk steels, FYD for the steels, which is 0.87 F YK. Okay, so you need to understand, you need to remember how the value come from, what's the properties for the concretes, and also what the properties for the steel. So these two here, okay, all of the safety factor we will use for the design. Sebelum nak design, you kena faham dulu where the equations come from. Okay, why we have all of these parameter, why we have all of this value. Okay. Okay, then we go for the durability requirements. So what is mean here? We want to provide the strength, the concrete beam that can perform in any circumstance, okay, in any problem, so that concrete can sustain, which is once that concrete exposed to the fire, to the any changes of the weather, that concrete still can perform, still can utilize all its strength. So that is meant by the durability requirement. Kita nak structure tu lasak, hujan, panas, corrosions or any impacts, so it still can perform. So easy to recommend all of this requirement, which is we consider about concrete cover. That means we have to provide this concrete cover. Uh, Consider about its minimum member dimensions. So that's mean for the beam, it have its recommended dimension, recommended sizings. Column also it have a recommended sizings. Okay, what that is what is meant by minimum member dimensions. Slab also what the recommended thickness for the slabs. Okay, then we also consider about it limits of reinforcement. So we have two limits, maximum and minimums area for the steel. Kalau maximum, we label as a AS, which is area for the steels, AS maximums. Okay, maximums reinforcements for the steels, and also we have a minimum which is AS minimum. Okay, that means you need to do the checkings from the AS that you provide. Okay, AS that you provide, let's say you provide 3 bars. Okay, let's say 3H 10, right? 3 bars with the diameter of 10 mm. According to the class of steel hatch here with the strength of 500. So this is the AS that you provide for the steels, okay, that you provide according to the bendings moments, okay, according to the maximum moments, okay, for the beams there. Okay, from AS that you provide, you need to check either it's within this limit. It should be more than AS mean and less than AS maximum. So it's more on checking. Okay, to ensure that you provide all the durability requirements, which is concrete cover, dimension of the member, and also limitations of the steels reinforcement. And the last one here is about the spacings. Okay, spacing is very important. What the spacing between this reinforcement, what the spacing reinforcement to the surface of the concrete. Okay, the spacing here will affect how the concretes can be inserted, can be fulfilled, can be coated around the reinforcement. You can imagine if you provide very small spacings, how the concretes, how the aggregates can be inserted between it. So that's why spacings also is a very important here. What is meant by concrete cover is from the surface of concrete, okay, to the links here. The surface of the concrete to the main bar. This is what is meant by concrete cover. Okay, then this is the spacings. Okay, the spacings between the bar, between the links. Okay, so we go how to determine the concrete cover. Okay, which label as a C norm. Okay, this is the very important part. So before you can proceed for the design, which is this is the initial calculations, which is from the beam sections. Before you can provide all of this reinforcement, you need to set up what's the concrete cover for the concrete. So this concrete cover, remember, it will protect the reinforcement inside from the fire. It will give longer times during the fire, right? Because of the concrete here, it can sustain the temperature, the high temperature better compared to the steel reinforcement. Kalau steels, exposed to the high temperature, so it will melt, right? Okay, compared to the concrete. So that's why the function, the purpose of concrete cover to protect, to resist from fire. Kita boleh delay the burning, delay the collapse. Okay, at the same time, apa ni? Uh, People can escape during that fire. Okay, then also concrete cover to protect the reinforcements from corrosions. Okay, because once concrete fallings, so this reinforcement will expose to the weather, will expose to the environments, to the chemicals that will enhance the corrosion problems. So that's why concrete cover is very important also to protect the steel reinforcement from corrosions. Okay, in EC2, provide these equations. So the equations for the concrete cover is equals to C min, which is minimum concrete cover that you need to provide, plus deviations. Deviation, it means allowance, another extra dimensions, okay, to be added up for safety. So that means C norm, concrete cover, is equal to C min plus deviations. So this is very important equation. So start from this equation, you can do your calculations. Okay, C min here, okay, have a three types of C min. The first is C min B. Second is a C min dur. The third one is a C min fire. Okay, so that means you need to select which one the maximum, which one is the maximum here that will be equal to the C minimum. Faham? So ada C min B, you kena check what is C min B, what is C min dur, what is C min fire. Compare these three, which one the maximum? So the maximums will be used for this, the value will be for the C min, for the C minimum. Okay, look at one by one here. C min B, that means B is stand for bond. Okay, remember the concrete and the steel should be perfectly bond together. The concrete, the fresh concrete should be coated around the steel reinforcement. So that's why that's what is meant by reinforced concrete is a composite. It should works well together. So that's mean we consider about its bond forces. Okay, so it stands by C min B. Okay, then the second is about the protections of corrosions durability. Okay, so from the durability, we take out a part of it, so it becomes C min dur. Okay, so this is how you can remember the symbols. Okay, the label. Kalau bond tadi guna C min B. Kalau durability C min dur. Kalau fire here, okay, resistance for the fire C min fire. Okay, any maximums here, okay, will be as a C min. So then deviations here is like a allowance. Dia bagi lagi extra, bagi lagi safety, kan? Which is the deviation is about 10 mm. So that means C min, C norm is equal to C min, any maximum between C min B, C min dur, C min fire, plus deviation about 10 mm. But some of the case, it just plus 5 mm according if it's subjected to quality insurance system. So that means might be that's manufacturer or developer wants some limitation of the dimensions, right? Because C norm here will affect the dimensions of the sections. Sebab if you look at this is the C norm, you need to provide this C norm. So that means the dimension will be some changes. Okay, will be more according to the C norm here. Okay, so this is how to determine the concrete cover. Okay, so that means you need to identify these three C min here in order to know what is the C min value. So the first one is the C min B for the bond forces. This C min you need to refer in Eurocode in tables 4.2. So this is your job to identify where these tables is. Okay. In the tables, it shows that there are two types of bars arrangements. Okay, which is from it you can know what's the C min B value. Kalau jenis separated, this is actually the common one. Okay, you also will go for this kind of designs. Okay, so selalu kita mesti susun separate because just for a common design, for a common buildings. Okay, so if separated here, so C min B is equal to diameter of bar. So let's see the diameter of bar is dual H20. So that means this 20 is equals to the C min bond. Okay, just according to the diameter of bar. Kalau diameter of bar ada dua, right? Let's say this is 2H20, while another one is let's say 1H16. You can go for the maximum one, okay, which is the diameter is equal to 20. Is equal to 20 mm. Okay, which is this is the C min value. Okay, then for the case for the bundles, especially for the structure that have to support the higher loads. Okay, so it make it into bundles here. Let's say for the bridge, kalau you lihat bridge kan, semua ada pre-stress that is like a tendons that's grouped as one bundles. That is according to the designs, right? So kalau jenis bundles, so you can determine the C min B based on this equation, okay, which is the diameter here, okay, is equals to, which is it also refer to the diameter. So which is what's the diameter is equal to the diameter of the steels, and then you have to multiply with this NB. NB is the numbers of bar in the bundles. So let's say one bundles ada 3 numbers of bar. There is 3 number of bars, so that means this is the value for the NB, okay, which is equal to 3 here. Okay, so but normally we go for the separated cases. Okay, so C min B is equal to the diameter of the bar. Then C min D, it based on the durability, minimum cover for durability to protect from the corrosions, especially. So it based on these tables. So these tables can be referred in the Eurocode for table 4.3. Okay, you need to find out these tables. There will be different classes. Remember, we have class S1 up to S6. Commonly we use for S4 because this class according to the design up to 50 years, right? Kalau jenis temporary structure, kelas berapa? S1, S2, I not remember. Kalau designs for the building for 100 years, so it S5 might be. Okay, so for 50 years is a S4 here. Okay, depends what's the informations given for that buildings. Okay, so the top one here is about the exposure class. Remember, what's the exposure or conditions for that structure? Is it low humidity or wet or dry? That buildings, that structure is outside the buildings or inside the buildings, or might be under the water. That's about the exposure of that structure. Um, uh, how durable of that structure, okay, to facing all the conditions. um, so let's say S4, okay, structure class S4, designed for 50 years, and then its types of with the exposure class of XC1. So that means this is the value for the Simin Dur. Simin Dur is equal to 15. Okay, based on what's the exposure class is. Exposure class, you need to refer these tables. These tables um, um, had introduced previously, right? Let's say XC1, okay, for the condition dry or permanent wet. Example, concrete inside building with low air humidity, or concrete permanently submerged in water. So you need to know. Kalau in real situations, you need to observe, go to the sites. Kan ada buat site investigations kan. Structure tu lokasinya di mana? What's the exposure or situation for that structure? So that is why site visit is very important. Okay, let's say XC1 ataupun XC4, or just concrete inside building with moderate or high air humidity, macam kita kat dalam bangunan ni, all the beams, column which is inside the building, okay, with moderate or high air humidity. So you need to select, you need to consider it as the XC3. Some of the question, it mentioned about the situation of that structure. Might be it mentioned, okay, these labs with low humidity. So it not mentioned what's the exposure class. So you need to refer these tables in order to know what's the exposure class for that slabs. Okay, ada soalan just directly mention this slab is categorized as a XC3. So that means you can just use of this XC3 in order to know what's the value for the Simindo. Okay, there are many classes here, right? So dalam slide tunjuk portion sikit je. So you kena refer dalam Eurocode in order to know what are the classes. Ada XD, XF, many exposure. Okay. Alright, so this S4 according to the structure, 50 years. How many years for that structure? Okay, kalau commons building, so we go for the S4. So S4, let's say XC1, so Simindur adalah 15. And one more thing here. Okay, remember for the Eurocode, sometimes the tables will relate to other tables. Contoh ni kita kena refer tables 4.3. At the same time, you need to refer the exposure class tables, and also at the same time, you also need to refer at this table, which is tables 4.3N here. Okay, what it mentioned here about reductions of the class. Okay, so kita pergi balik sini. Okay, look at here. So kalau S4, okay, kalau S4 here, sekejap ni. So this is special for the S4. Okay, in the case of structure class for S4, there will be a reductions or increasing class. Let's say S4 here, reduce class by 1 S4. Maksudnya kalau dekat S4, you kena reduce class to be S3. So that's mean you need to refer value S3 here. Okay, uh, according to the requirement from the table 4.3n. So some of the cases, if fulfill the requirement in table 4.3n, you kena increase the class from S4 to be S6, which is lompat 2. Kalau memenuhi requirement dalam table 4.3n, you kena reduce the class or increase the class to be S6. Kalau tambah class S6, so that means XC1 will be 25. Sama ada reduce or increase the class, it based on this table. Kan, jangan pening. So you need to refer this table. Either you have to reduce the class or increase the class, or might be just stick with that class, just stick with that S4 kalau tak fulfill all this requirement. Let's say, okay, this is the strength class here. Okay, ni kalau dia punya criteria to designs up to 100 years. Let's say you just according to the strength class, which is grade berapa. Okay, kalau concrete strength that you use more than 30, okay, 37s for cylinder, for the cube here, if more or equal of it, okay, so you need to reduce class by 1. Kalau guna concrete strength 25, tak payahlah, still guna S4. Kalau grade concrete C30, which is equal, you need to reduce the class. So you need to refer the simindul in the S3. Okay, so this is descriptions, okay, the requirements. Either you need to reduce or increase the class. Kalau design working life up to 100 years, kalau any of XC1 here, you need to increase class by 2. Okay, so increase class by 2. Kalau contoh, you need to design that structure for 100 years working life. Okay, so that means you need to use S6. Okay, you need to use S6, which is 20, 25 here. So let's say just 50 years, but the concrete strength more than C30. Okay, that is mentioned in these tables here. Okay, kalau guna XC2, lain dia punya requirement, dia punya strength. Kalau guna XC4, kalau guna concrete strength more than 40, so you need to reduce class by 1. So that means you need to reduce class by 1. So you need to refer the simindul based on S3 here. Kalau XC4 tadi, so simindul is equal to 25. How is it? Can you understand me? Faham tak? Oh, senyap je. Tengah makan semprit ke apa? Faham tak? Hello?
Faham.
Faham Kalau tak faham saya ulang balik. Itu je. Okay. Alright. Nanti ada contoh, you akan lebih faham lah. Okay. Bila melibatkan you code, you kena bersedialah dari satu table you akan refer ke satu table yang lain. Okay, itu untuk C min dur. Okay, I repeat back. C min B. Okay, C min B just refer dia punya diameter bar. Berapa saja diameter bar itu adalah C min B. As long as it in the case of separated. Okay, kalau bundles, it difference here. Okay, depends on the equations here. Okay, kalau C min dur, you need to refer this first table. Structure class berapa, exposure class berapa. Okay, then kalau S4 here, special for the S4. Kalau S lain, just maintain directly, take all of the value. Kalau S4, okay, so there will be some tables that you need to refer. Okay, which is the recommended structure class design working length of 50 years, which is S4. So there will be some modifications. Either you can reduce the class or increase the class based on these tables. Okay, so just follow, reduce or increase. Okay, depends criteria untuk hundreds years according to the strengths of the concrete. For the member with the slab geometry or any special quality control. Okay, mungkin dalam contoh subject ni, we just go for the strength class, right? So this only the example that we can give you. But in the real real designs, bila you dah design nanti, there will be a various types of building. There will be many situations, problems that you will have an experience. So maybe you will experience refer for these labs or refer any specials quality here. Okay, so untuk contoh memang kita just focus for the strength. Nanti dah kerja kan, you akan jumpa macam-macam situations, many kinds of structure. So you will utilize all of these parameter in the table. Okay, C min B sudah, C min dur sudah, then we go for the C min fire. Okay, so for the C min fire, okay, it's according to this equation, these two equations. Okay, for the C min fire. So that means you need to refer this one first. This is the first equation, which is C min fire is according to the ASD. ASD actually is a distance. Okay, is the distance from the side of the beam to the corner bar. Okay, this is the corner bar. This is the corner bar. Kan, kat ujung sekali dekat corner. So that is mean by the ASD. From the sides, from the surface of the concrete to the center of the corner bar. Okay, to the center of the corner bar. This one also can be ASD. So is equal to ASD minus diameter length minus this diameter length minus half of diameter bar, minus half of diameter bar. So yang lastly dapat apa? Inilah concrete cover for the fire. Okay, ASD from side to this corner minus length minus half of the bar. So this is the only of C min fire. Okay, how to determine the ASD is based on this equation. So this is the equations number 2 that you need to determine. Okay, ASD here is equal to A. What is A? Is the distance from the center of the bar, is the center of the main bar, okay, to the top or bottom surface of the beam. So that means which is from the center of bar to this side here. So this is A. Okay, it's like more on the verticals one here. Okay, the verticals directions here, the verticals length is from apa ni, dari center of diameter bar to this side here. Okay, so this is horizontal directions, right? Which is, we call it as a ASD. So SD and A is about the dimensions, okay, from the center of the bar to the sides of the beam, to the surface of the concrete. That is A here, plus 10. That means safety, another allowance that is given, okay, for the fire. Okay, so to determine the ASD, it's according to these tables. Okay, sebelum nak tahu C mean fire is equal to SD minus all the diameter links and bar here, you need to know what is ASD. So this ASD, okay, is according to the table 5.5 and 5.6. 5.5 for simply supported beam, 5.6 for continuous beam. So it depends what's the fire resistance for that structure. R30, that means that structure can sustain during 30 minutes for the fire. Okay, dia boleh bertahan 30 minit semasa kebakaran. R60, about 60 minutes resistance for the fire. So depends what's the requirements for that building, how strong, how quality that you want to provide for that structure. Remember, once you provide high quality, that means it affects the cost. So it's that means is about budget. Okay, is about the cost of the projects. Kalau dalam consultant it mentioned this structure can resist the fire about 60 minutes. So this is the requirements that you will consider for the designs. Okay, this is also according to the width or dimensions of the beam. Beam mean here is the width of beam. Berapa size you punya beams tu? Kan, katalah 200, about 200 mm. So B means is about 200 here. So B mean 200. That mean you punya A adalah 30. Okay, you punya A adalah 30. Okay, katalah guna R90. Tapi size beam 300. So that means value for A is 40. Okay, so this 40 will be included in this equation. So 40 plus 50, that means let's say 40 for A according to these tables, which are 90. So 40, okay, from the table plus 10. So that means you punya ASD adalah 50. So insert or replace this 50 in this equation. 50 minus diameter length minus half of diameter member. So that is how to calculate the cement fire. If you look at in these tables, it also mentioned here, okay, for value of B mean greater than that given in column 4, look at of this column 4 here. Okay, no increase of ASD is required. So that's mean kalau column 4, it's mentioned here column 3. So kalau B mean greater than that given in column 4. Let's say this is the 200 here. Kalau 250, katalah 250, belum sampai 300 lagi kan, 250, so you akan guna 30. Kalau 260, you akan guna 30. So no increase of SD is required. Okay. So for the continuous, kalau column 3 here, okay, sama juga, it mentioned about this column 3. No increase of ASD is required. Ataupun sekejap. No increase of ASD is required. Oh, sorry. That means you don't have to plus with this 10 here. Okay, so just guna 30. Okay, ASD, which is ASD is equal to A. Itu maksudnya kan, ASD is equal to A here. So this one also ASD is equal to A. So there's no increments. Okay, there's no allowance to be considered. Okay, so cuba kita lihat examples ni. You nak take a break kejap ke? Nak take a break or proceed? Take a break. Okay. Lambat nak fikir kan? Nak fikir nak take a break ke tak nak take a break ke tak? Lambat nak fikir okay, so kita stop kejap Alright. Kita continue 11.30 lah. Alright. Okay, sambung eh. Alright, kalau lihat dalam examples, you need to determine the concrete cover of the simply supported beam here. Okay, so that means you need to determine the C norm, the concrete cover for this beam section. It given this is the B width of the beams. Okay, the design life of 50 years. That means you will use S for fire resistant, R60. That means this beam sections can resist its durability for the fire around 60 minutes. Exposure class XC1s, you can refer the tables. What is XC1s? What's the exposure for these beam sections? Bar diameter, which is this is bar diameter 20 mm. Diameter length, this is the diameter length, which is 8 mm. This is 20 mm. FCK for the concrete 25, FYK is 500 here. Okay, which is this is the type of H class. Okay, so this all information is just simply given, okay, in order to determine the concrete cover. Okay, nama pun examples, semua senang, semua bagi. Okay, tapi kalau in exams especially, there will be a statements might be about the situations of the concretes, what's the exposure, rather than just simply give a exposure class, for example. Okay. Okay, so remember for the equations of the C norm is equal to C min plus deviations, right? Okay, so this is the equation for the concrete cover. So for the C min, it have a three C min. We have a C min B, we have a C min dur, and also we have a C min for the fire. Okay, for the fire here. Okay, so you need to determine why one by one here. Okay, at the end you will select which one the maximum one, okay, to be as a C min. Okay, look at one by one here. First, you need to determine C min B, okay, for the bond, which is, if you look at here, this is type of separated, okay, separated diameter. That's mean C min B is equal to diameter of the bar. The diameter of the bar is a 20 mm. So that's why C min B is equal to 20 mm. Okay, then for durability, which is C min dur, okay, so this is based on the exposure, it's based on the condition. So this beam sections, it mentioned S4 and XC1. So the value for the C min dur is 15. Okay, that's you need to refer of these tables 4.4n here. Okay, so then you also need to refer of the B means, right? Is it you have to reduce or increase the class? So kalau lihat kat sini it just 15 here. That means there's no requirement to reduce or increase the class, okay, because of this B min here is a 250. Okay, kalau kita lihat balik, okay, XC1 kan, so dia punya grade concrete berapa? 25. Dia punya grade concrete 25. So that means kalau you refer in this table 4.3n strength class, okay, which is for the HC1, grade concrete more or equal to 30. Tapi dalam soalan grade concrete dia 25. So that means you can just ignore of these requirements. It's not fulfill of these requirements. So that's why you can just stick, okay, directly. As for XC1, guna 15 as a semin door. Kalau grade concrete more or equal than 30 here, you need to reduce class by 1. So that means it become S3, so you punya XC1s becomes 10. Faham Okay, so dalam case ni just maintain XC1s which is 15 here. Okay, so dah dapat semen B, semen dur, and then we go for a semen fire. So which is based on resistance of 60 hours, 60 minutes. Okay, 60 minutes. This is in the table 5.5. Look at for the value of R60, dia punya B is a 250. So just use of B of about 200s. Okay, it still not reach 300s, right? So just refer the lowest one. So nilai A adalah 30 here. Okay, so once you want to calculate the ASD, that means ASD is equal to A plus 10. So this is a A, okay, the A value from table 5.5, 30 plus 10, the allowance. Okay, remember ASD is equal to A plus 10, which is this A from this table. Okay, so ASD is 40. So insert this 40 in equations of semen fire. This is semen fire, which is ASD 40 minus the diameter of the link, which is all the diameter is already given, minus the main diameter divided by 2, half, right? Half of the diameter here. Okay, so semen fire is 22. So compare these three semen, which one the maximums? This is the maximum. Semen fire is the maximum one. So this semen fire will be the semen, will be the selected of the semen, okay, based on the maximums one, plus the deviations here. So 22 plus 10, so you need to use this concrete cover 32 mm, okay, for in the beam sections. Okay, so 32, that means ni adalah you punya concrete cover. You need to provide this 32 to be the concrete cover. Okay, this 32, this horizontal, the vertical also 32, all the sides from the from the surface of the concrete to the nearest bar here, which is links, it should be at least 32 mm. If you want to provide 40, also can. Okay, but at least you need to provide the concrete cover 32 mm. So that means apa ni, during the installations of the reinforcement cage, you need to measure, you need to check at site, this concrete cover must be 32 or more than it. Okay, so kalau tak cukup, kena ubah balik, kena betulkan balik apa ni, the sizing. Okay. Okay, then finish for concrete cover. Then we go for other durability requirement, which is how to determine the minimum and also the maximum area of reinforcement, which is it just according to these equations. Okay, actually this equation it come from this equation. Replace all the coefficients here, which is you can refer in section 7.3.2 here. Then finally it will come up by this equation for the AS mean. You just need to remember or take notes of this equation in order to know what is the AS mean. Is equal to 0.26 FSTM. This is the value that can be referred in the table. Also, I'm not remember what's the table is in the Euro code here. Okay, and then FYK, what's the strength of the steel? FCTM is actually uh, is the strength of the concrete. Okay, but it's not FCK, it's FCTM here. Another value besides FCK. Okay, based on the tables, and then BTD. B is the width of the uh, concrete of the beam sections, and then D is the depth of the beam sections here. Okay, so this AS mean is equal to 0.6 FCTM divided by FYKB BD, but this value not less than 0.0013 BD. Kalau lebih, kalau nilai ni lebih daripada 0.0013 BD ni, you need to use this value for comparison, for checking. Okay. Then we have another one, AS maximum. AS maximum is equal to 0.04 AC. What is AC? Is the area for the concrete. So that means if dimension is 200 times 300, this is the area for the beams sections. Okay, what is meant by AC here? All right, so that means the area of reinforcement that you provide, let's say from the moments maximums you calculate, then you will get this 2H16. So this 2H16, that means this is the area AS that you provide. You need to calculate what's the area according to 2H16, right? So nak kira area, kira lah diameter of the bar, right? The area for the diameter of 16 kali dengan dua bar. That is what is meant by AS provided. So checking for AS mean, checking for AS max, the value for AS provided must be within AS minimum and AS maximums. Okay. Okay, then for the spacing here. Okay, for the spacings. Okay, again, why we have to provide the spacings in order to allow the concrete mix of floors around the reinforcement, make sure it's coated around the steel bar. Okay, so that's why we also want to provide the adequate bonding between the concretes and also the steel reinforcement. So this is the guidelines. Okay, that means we should not. That means we should provide the distance or the spacing between the bar. Okay, the clear distance between bar, okay, the distance between bar should not be less than the maximum of these three. So that means you also need to compare these three in order to know what's the spacing that should be provided. Okay, the first one, the maximum bar size. Okay, let's say if you provide different diameter of bar, okay, so you need to consider the maximum one, okay, as a considerations in order to know is it adequate or not once you want to provide the spacings. Okay, the maximum aggregate size, normally aggregate size about 20 mm. So 20 mm plus 5, so 25 mm. So nak justify betul ke tak size aggregate yang you guna adalah 20 mm, you kena buat sieve analysis kan. So masukkan dalam tray tu ada sizing kan. So the maximums kalau dekat lab selalunya 20 mm. Okay, the third requirement here 20 mm. Ni memang dah specified by the Eurocode. So you need to compare. The spacing should not less than the maximum one here. Let's say bar size. Katalah this corner bar is 20. This internals bar is 16 mm. Kan? Ni all the corners bar is 20. So the maximum bar size here is 20. So the first requirements consideration is 20 mm. The second, maximum aggregate plus 5 mm additional, the allowance one. So it becomes 25. 20 mm that is specified by the Eurocode. That means Eurocode mentioned at least spacing should be 20. So that's why it mentioned 20 mm by the Eurocode. Then you compare 20 mm, 25 and 20 mm also by the Eurocode. The maximum one is a 25. So that means the spacing between bar must be at least 25 mm. So that means the gap here, the spacing between bar is a 25. Either horizontal or vertical, it should be 25 mm in order to ensure that all the mixed concretes can coated sufficiently between the bars. And then we also provide the adequate bonding between the concretes and also the bar. Okay. Kalau you imagine the real situations, let's say you provide the gap between the reinforcement about 15 mm. Kan? Katalah you provide spacing ni 15 mm saja. So tapi you punya aggregate size is about 20 mm. Right, for the concrete, aggregate plus cement plus water cement ratio, but the aggregate size is 20 mm. So how gonna be this 20 mm of aggregates can be fill up between this spacing. So that's why the spacings of reinforcement is very important. Okay, and for the first part, okay, so this is summarized. You need to know what is FCK. Remember, FCK is equal to 0.567. FCK for the steels, FYK is equal to 0.817. FYK 5, 6, 7 FCK ni akan guna dalam design nanti. And then concrete cover, which is C now, we have C mean B is according to the diameter of the bar. For the separated case, we have a C mean durability which is related to the exposure situations of that structure. And then C mean fire depends what's the hours resistant for the fire. Is it about 60 minutes or 90 minutes, 1 to 0 minutes according to the requirement of the project. Based on this, you need to determine what's the maximum in order to calculate in the equation of the C norm, or C norm is mean C nominal, concrete cover nominal. Okay, norm it here it stands for nominal. Then another requirement about the minimum and maximum area of reinforcement. It have equations, right? What is the equation for S minimum? What is the equation for the AS maximum? These two you need to compare with the AS that you provide in the beam sections. Okay, and then reinforcement spacing. What the spacing between bar here to ensure that you give sufficient gaps between it for the concrete to be filled up around the bars, between the bars here. Okay, that's it for the part one. Okay, we'll show you another examples here. These examples you can refer in another notes, right? In other notes of continuous beam. Dalam author ada continuous beam design. So you tengok, the first thing is you need to identify dia punya concrete cover before you can proceed, before you can decide what's the beam sizings, what the sections, dimensions of the beams here. Okay, so it mentions here about the beam dimensions, dia punya width, sebab kita nak tahu dia punya width kan dalam apa ni requirement for the cement. Okay, and then this is a design life of 50 years, so that's mean S4. Loading tak digunakan untuk apa ni determine the concrete cover, and then requirement for 2-hour resistant to fire. So that means 2 hour R1 to O, right? It mentioned external, in an external but sheltered environment. So dia bagi situations. You kena match discrete situations in the tables. Okay, it mentioned external. That means this structure is built. The location is outside the building, but sheltered environment. So dia ada tutup lah apa semua kan, cover. With these types of situation, you need to know what's the XC, XC1, XC2, depends what's the exposure class for this structure. It mentions here, this is the specification. Might be this is becomes the solutions. You come up with this solution. So it mentioned here XC3 plus XF1. So there are the combinations of situations here. It mentioned also secondarily, dia punya apa, humidity. So ada lagi dia punya situation exposure here is designed for moderate humidity or cyclic wet and dry, and secondarily for moderate water saturation kan. Dah pening. Okay, so from the checkings in the tables is about XC3 plus XF1. Okay, so because of estimations, you can decide you want to refer the value of XC3 or XF1. Okay, so this is all the data. You also need to know the diameter for the links, right? The diameter for the bar, ada tension bar, ada compression bar. So kalau tensions bar, This is the tensions bar, which is 25. This is the compressions bar, which is 12 mm. Okay. Then so you need to compare all the semin for durability, for the fire, for the bond, right? We have a 3 semin. First, yang paling senang, that's why we start with the semin B. Okay, for the bond, just refer the diameter of the bar. So the diameter of the bar, we have here tension is 25 mm. Okay, uh, so dia tak mention separated or bundle. We just go for the commons situation, commons arrangement of the bar which is separated. Okay, C min B 25. Okay, then for the durability. Okay, for the durability, nanti you C min do here 25. So kita boleh cari C min do. Okay, semindul is according to the its exposure, right? So S4, dia punya tadi apa? XC3, right? XC3 dengan satu lagi XF. So we just you can select either one, which one for the estimations. So XC3 is 25 here. Okay. Okay, so semindul is a 25. Okay, and then we go for the fire. Okay, fire tadi they mentioned 2 hours, right? So that's mean R120. So there's some mistakes in this example. So you kena betulkan this is actually R120. Example ada je yang salah kan? So 120, so then refer the tables, berapa 120 for the fire. Kalau saya lihat, kalau kita try lihat. Okay, katalah R120 here. Okay, dia punya B min is a 300, right? Okay, so that's mean A value is a 55. Okay, 55. So supposedly this one is a 55 here. You nampak tak? Lagi lama apa ni durations for fire resistant. So the thickness of the concrete cover apa ni becomes thickens. Okay, makin tebal. Okay, so 55 plus 10, so it's equal here to 65 here. Right, so this 65 should be included, should be replaced in this value. Betulkan balik This is 65. So you have to minus with the links, minus with half of the main bar, right? And then what is the C min here? So this is the deviation. So which one the maximum one? Ni dah salah kan? So you need to calculate back which one the maximum one that will be replaced in this value plus then at the end there will be actual the concrete cover, okay, for this example of continuous beam. Oh sorry, continuous beam. Tak ada siapa mention tadi continuous beam. You kena refer table 5.6. You need to refer this table 5.6. Dalam soalan ni continuous beam kan, supaya saya ingat, korang senyap je. Continuous beam R120, so that's mean 35 here, 35, right? Dia punya B dia 300, right? 300, so A adalah 35. Okay, so maintain ambil 35. So actually this is the 35 here. Betul tak korang?
Betul doktor.
Kan 35 ni. So kena hati-hatilah. Is it table for simply supported ataupun table continuous. Ni 35. So plus dapat 45. So this should be 45. Cuba calculate 45 minus 12 minus half 25 dapat berapa? Kita terus betulkan.